Welcome to the Maths Master Blaster. Today we're focusing on Euclidean geometry grade 11 and 12. We're focusing on proofs which are examinable in grade 12 and also some are examinable in grade 11. So the guideline or the unit 5 was extracted from the last push, from KZN last push, which it was compiled obviously by the KZN's Department of Education. So now let's look at the theorem, starting from the first theorem, which states that if a line is drawn from the center of the circle perpendicular to the chord and then it bisects the chord. So now let's look at the word if. The word if here in our sentence, the word if a line, that tells us there is a condition. It tells us about the condition. If, for example, let's put this in a real life situation where you say if, where a person or individual, any person says, if it rains today, then we'll stay at home. That means if it can rain, there is a condition. If it can rain, they will definitely stay at home. So now let's look at this in a theorem. If a line is drawn from the center of the circle, we're talking about this line. If a line is drawn from the center of the circle and it is perpendicular to the chord, it forms 90 degrees with the chord and then it bisects the chord. It means then now the word bisect, it divides the chord into two equal parts. Okay, now we need to prove that indeed, yes, it does bisect the chord, because you have made a condition or a claim that the line, when a line is drawn from the center of the circle perpendicular to the chord and then it bisects the chord. So now you need to prove whether it does bisect the chord or not. Okay, the first thing when we prove, we're going to start with construction. And on our construction, we're going to say join AC and AB. So we have the two. So let's go. We're going to have AB and AC. Let's now construct. And then let's construct again. There we go. So we have constructed now. Okay, so we now have two triangles, which is what and what, which is we have triangle ADC and triangle ADB. Those are two triangles that we have, and we'll be working from those two triangles. And remember, we said the line drawn from the center of the circle perpendicular to the chord. So now the claims if, and then that is perpendicular to the chord, it means it forms 90 degrees with the chord. Okay, let's take a look now. Then if it forms 90 degrees with the chord, that implies that this angle ADC it's equal to angle ADB, which is equal to 90 degrees. We said it forms 90 degrees. Then it's given from our claim, right? Okay, so going forward now, looking at these two triangles, we can see that we have AB and also AC. So those are lines drawn from the center of the circle to the circumference and are equal. Okay, then now let's take them. We have AB, which we say it is equal to AC. Then the reason are radii. So those are radius, line drawn from the center of the circle to the circumference, and there are two. Okay. Oops. Okay, let's take them back. Right now, looking at the triangles again, we have this side, which is common. It's contained in triangle ADC, and it is also contained in triangle ADB. So those are common sides. It's common in both triangles. Then we're going to have AD from the other triangle. It's equal to AD from the other triangle. It's common. It's one. Then you can say those are common sides. So now you have proven that the angle and the two sides from both triangles are equal. Then in that case, now we can conclude that the two triangles, which is triangle A, DC, it is congruent to triangle ADB. Why are we saying they're congruent? Right hand hypotenuse side, RHS. Therefore, they are congruent. And then if the two triangles, they are congruent, and then now we can say also the remaining side, which is CD, because we said they are congruent, we said everything are the same in those two triangles. Then we can say, therefore, CD from a triangle ADC, it is equal to AB. That would be DB. That would be DB. And then now in that case, now you have proven that it bisects the chord, because you've said this. Now it is equal to that, because you said CD is equals to BD. Then in that case, now we have proven that a line drawn from the center of the circle perpendicular to the chord, it bisects the chord, it divides the chord